Hello, Tiercon4 here, and I'm going to be doing a, hopefully, fairly quick and simple example of how to set up auto buffs. Basic video tutorial of setting up on a character. So, first, go to auto debuffs, buffs, go to blueprints, and go here to the buffs boolean and enumerator and buffs float enumerator, and open those. So, the float enumerator is basically various float values, things which you want to have like a multiplier or an additive value for, or subtractive, like damage taken, damage dealt, movement speed, or in an RPG you might have strength and agility and stuff. So just like your agility and, I don't know, wisdom. You're a wizard. So you could have whatever your different values are here that you need in your game. Best to figure this out before you start, but you can make changes later on whenever you need. But so first, you need to know what you want in your game. The example ones that I have are damage taken, damage dealt, movement speed, and so on. Here we just add agility and wisdom. Save. Next, we'll go to the buffs boolean. This is more of like a state, a true or a false. For example, are you silenced? This could be things that have provided silent state mean you can't cast spells, or we could say that there is a state where you are stunned. You just can't do stuff in general. Or maybe there's a state where you are invincible. You got the flower, the firefly, what was that? The starlight, the star from Mario. You can't be damaged or something for a given duration. No knockback, whatever. So whatever states you happen to have in your game, just add them in here, and whatever various stat values that are being adjusted or changed, you add here to the buffs float enumerator. So change these and save them. After that, go to auto buffs blueprint, which can be found just over here, also under auto buffs blueprints. Go to here and compile. After you've changed those, you need to compile it so it can actually work with these. And anything else referencing it's also going to need a fresh compile. So in this case, we would go to the auto buffs actors, third person character BP, and he would need a compile. As an example, for the record, up here is more or less default stuff. Here we've got some basic code for spawning projectiles, attacks, and stuff, but down here is more or less where all of the actual auto buffs code we've set up on this character is going on. In order to actually use the auto buffs on a character, first things first, you go to class settings, and you'll need to add auto buffs blueprint interface. Then you'll need to add the auto buffs component itself. Once you've done both of these and compiled, then you can create these event buff added nodes, which are based off of the auto buffs blueprint interface. Using these, they provide you with various values, which you can pull out and create a simple switch node. But in this case, rather than going from scratch, we'll just copy paste on our example character later. But the overview of what this basically is whenever a buff is added or a buff is removed, we can use that to say what type is it, and then based on which type, we can create an enumerator for that, which now shows damage taken, damage dealt, movement speed, agility, wisdom, whatever here values we'd created here, we now get over here. And with these, we can then say here for movement speed, if it's updated, we will update the movement speed. If movement speed is a buff that was removed for movement speed, we'll also update the movement speed. And in this case, movement speed is basically just saying character movement, which is from the character movement component. We're going to take the base walk speed. We're going to add any flat value changes to it. And we're going to then multiply that by the new multiplier. And we'll get our new max walk speed. Simple enough. Now, in order to actually put this on a new character, though, so, nope, here's here we are, new character. So, basically, there's just a new blank character off in a content third person blueprints character. Nothing really of note about them, just, yeah. So, what we got to do first, add auto buffs. Then you go to class defaults and class settings and go to implemented interfaces and add auto buffs BPI, then compile. And with that, we'll just go to the example character and copy paste this area because that is frankly fastest and easiest. So go into the event graph of our new character, we'll just paste, hit confirm, and right click and refresh node so these references are now referencing proper nodes present here. Still, things like this base walk speed, we'll have to create that variable. Update projectile speed, we didn't bother adding that on this one, so we'll just get rid of those examples for right now. Over here is an example of creating user interfaces, where after we made those changes for whatever it was using the sequence node, we would also add or remove a user interface icon showing what buffs we had. You may be doing this, you might not be in your game. You might be sending this to a general user interface which shows stuff. You might be creating one-off widgets like this example here. Whatever the case, this is pretty much everything after this section is up to you to figure out in your own game-specific cases. So up here, that's you send it to your own master widget, whatever. And after here is based on you make whatever change. Like if you've got an agility stat change, that might affect movement speed, it might affect your jump height, it might affect whatever. All that would be stuff that you'd be setting up in your own game based on what you want that stat to affect. But here we'll just go and create some basic values, and this way we can make use of the example little user interface setup. And then base walk speed should be, I think, around 500. So compile. Something don't be liking that. Right. Because we're not actually including those ones to keep this simple. There, compile. So basically what will happen now is, first, we created our new stats that we need using the buffs flow enum and the buffs boolean enum. Then we go to our new character and we add the auto buffs component and go up to class settings and we added the auto buffs split interface. Then we compiled. And then we simply, to be quick about it, copied and pasted this example code from the example character. What this now means is if we receive a buff event or the auto buffs component receives the buff event, it will, if that buff affects our character, say, hey, you've got a new buff added. And if one's removed, its timer runs out or whatever, it will say, hey, your buff is removed. Assuming a buff is added, in this case, we just made a custom event that's set to multicast to replicate for multiplayer purposes. In this case, the buff being added, we first switch based on its category. You can just, again, type switch to create these nodes. So we switch what category is it, and then after that, we do a switch based on the given type that it was, and then we would, from there, like, again, if it's agility, you would come and link up to a custom event you've created to handle agility stuff, like, say, add custom event update agility. So in that case, then you would have, if agility changed, you'd do the update agility. And you also want to update it if it gets removed. So update agility. Basically, this is just telling you something's changed and you need to update or whatever on your character, assuming that your character actually is regularly using that. It might be the case that your character only needs to reference something when it is directly on rare occasion, in which case you might not bother updating stuff. You might just, whenever a given event or action happens, get a reference to stuff. So how do we actually get those references? You basically just take auto buffs, drag it out, hold control, and you can get the reference. And then you get float struct arrays. There's the multiplier, and up here, as you can see, the flat one. Flat is basically used for plus and minus values, like, say, +5, +10, -2, and the multiplier is like plus a 0.2 or 0.5 or a 5, but this is used to multiply your whole stats or whatever by it, while the flat is used as simple basic additions. They stack, these multiply. You might have different types of buffs going on, so you can have both types at once. So, and then you get a specific one by, in this case here, you'll notice we're going for movement, and we're getting get a copy, and you can right click and split struct pin to expand those. But in this case there. we're using the value of 2. Why? Because if you go back here to our buffs float enumerator list, we have damage taken. Assume that this is an array, indexing starting at 0. So 0, 1, 2, 3, 4, and going on. So that means 0, 1, 2. So movement speed is the value 2 in this index. So going back to our character, that means value 2 is movement speed. So we're getting the float flat value clamped out of this, and we're adding that to our base walk speed. And then the multiplicative value, which we could also get from down here, though in this case was being provided as a quick float value up here, and being forwarded directly through the update movement speed option. We're basically using this in order to set the new max walk speed to include these new buff changes. Again, what exactly you're doing here and stuff is all up to you and how you're applying these new stat changes yourself. This simply has a stat change. Like maybe you've got plus 10 or 20, and for the multiplier one, you've got like 0.5 bonus, so a total of 1.5 is your final multiplier. You then do with those as you will. But with this, we've got a character who, in theory now, we could pick up these buffs with. That said, let's look at how to actually apply buffs. So Control B and open this up. Basically, that is something that overlaps this. It will send a buff. So here we have on begin overlap and on end overlap. On beginning overlap, first, is this a server? We only want to send the buff messages if this is the server. Actor has tag. In this case, imagine you want to launch a debuff or a buff, and you want the buff to only affect your allies. Then you could say whatever method you have of picking up people from friend or foe or whatever. In this case, an example is, does the actor have a faction tag? So these example boxes are only going to really work on a character that has this tag. Basic example, if we want this on our new characters, go to class settings tag, or sorry, class defaults tag, and make sure that you have a tag value here. If you don't have one by default, which you wouldn't, you just click this and add that. Alternatively, you could just not bother having that. Say, for example, you have fire. Somebody's put fire on the ground. Fire is an equal opportunist. It will burn everyone. So in that case, you would not need to have something like this. You could basically just skip this. You don't care who's who. You're burning everyone all the same. But if you want something to only affect one side, this is how you do that. Either way, then your other actor, which is whether line tracing to shoot somebody or here overlap because somebody walked over something, get your reference to the actor in question, and then do a get components by class, and then you would set that to auto buffs BP. This will effectively, for whatever actor you have, if it has auto buffs, that's what it's going to return that component's reference. First, we want to check is valid, because say a random boulder or something, a barrel gets rolled into the area that doesn't receive buffs, then you don't want to be trying to send stuff because there's nothing there to send stuff to. But if something does have this component, then it's probably like a character, something that can receive them, so then we will in fact send these. So if it is valid, we get the reference out here, and do like a float multiplier buff, because in this case we're using a float. Or you can just do whatever buff. Float flat, a status buff, or a boolean. And generally speaking, you're going to want to use these message versions over the other ones that are going to be present. But yeah, so float, flat, buff as an example. If you wanted to create like a +5 value. Here we've got a multiplier, so by default this example movement cube gives you a multiplier of 1.2. First option for, let's go over these option by option. First, float buff type, movement speed, damage taken. You just pick whichever stat this affects. Multiplier order, additive before multiplicative, multiplicative, additive after multiplicative. Basically affects which order the math is applied in for multiplicative stuff. You'll notice it's not present on the flat one, just the first. Then here you have multiplier change, which is again is like 1.2 times, 1.5 times, whatever. Or over here, stat change being flat would be like +5, -2, whatever. The effect's duration. How long will the effect last? You can have a single application that say lasts 5 seconds, in which case after 5 seconds it will be automatically removed by the auto buff system. Or here we do -1 because there's a negative value, then the auto buff system identifies that this thing is indefinite, it's not going to disappear. In that case, it will stick with you forever unless otherwise removed. Next, we have clear existing. Clear existing, here when you leave, do the end overlap event, you'll notice this one uses clear existing. It uses that to remove a buff. How does it do this? By using the buff ID. In this case, we're saying this particular buff has this ID. It's just a random number that you make and assign to each buff type. And with that, you can clear an existing buff with the same ID or replace an existing duration of a buff with a given ID. Say you have a buff that improves movement speed by 10%, and you want to, say, not have it stack. So it lasts 10 seconds. Somebody casts on a character, and after 5 seconds they casted it again. Then if you have replace existing duration, and you've got the same ID, it will reset that buff's duration. If you're not using unique IDs, though, then when you cast it again, you'll have 2 separate buffs, each with their own timer, and now for the next, in that case, 5 seconds, you'll have both buffs applied. In which case, you'd suddenly have like 20% increased movement speed, which maybe you want that, maybe you don't, but you might not want to have a character that can easily stack a given type of buff too easily. It depends on your game and what you want, but you can use these options. Then buff info is basically just, you could split struct, or just promote to a variable and set the values of the variable, whatever. This is for user interface purposes. You got a material, a tooltip, and a name, which is, useful for the user interface side to actually know what it is and how to display it. And then, when you end the overlap, we're pretty much doing the same thing, but calling clear existing using the same buff ID. And that's a basic example of how to set this up. So, with the, our new character, go here to auto-possess, set them to possess 0, take the old one, auto-possess disabled, and we'll give this a quick little run around. And as we enter here, we will speed up, and we can pick up these buffs, as you can see in the lower left corner. And that's pretty much an example of what this is. All this really takes is, again, so first, you want to go here to these enumerators, set whatever particular stats you happen to need for your game and states. Then you go to auto buffs, compile and save after you've made those changes. Then you'll go to your character. You'll want to go to class defaults and add, class settings, let's mess those up. Add the interface, auto buffs, blueprint interface. Then you'll want to go and add the component, auto buffs, blueprint, the component. And once you've done this, to expedite things, you could just copy and paste stuff from the example character, but you're going to want to create the events after you compile for a buff being added and a buff being removed. Whether you plug these directly into these or not, based on a replicated game or not, easiest to still just copy in general anyway. But after that, you then, when a buff is added, you just break down what type it is, and then create a switch for that given buff type. And based on whatever the output is, you will simply call the events in your own game to make whatever changes are needed. In order to access given changes, you simply get the float flat structure at any time or the float multiplier structure at any time. And using these, and knowing which index your given modifier is for, you can, anytime you want, access them. Or, when a new value is changed, you can just get that value directly from the buff changed value, which means you could pretty much just take this and take our new multiplier and multiply based on this. That wouldn't really have to be included in this case, but it was more so just to teach an example. So with that, hopefully you found this useful, and there's some more details in the documentation itself, but this is the basics of all it really takes to add is just, again, set your basic stats, add your blueprint interface, add your component, create the events needed in order to inform you of when a buff has been added or removed, and then on your own, create whatever changes you need, such as here, updating the movement speed of your character's movement component when the movement changes, or adding and creating new user interface elements when buffs are added or removed. Hopefully this helped. If you have any more questions, post them down below. And until next time, stay healthy and have a productive day, everybody. Toodles.